Hello everyone. Our topic today will introduce a new kind of fuzzing on Android, from quantitative change to qualitative change. Actually, it's a new fuzzing perspective to improve the existing fuzzing tools, such as AFL. So let me introduce ourselves at first. I'm Zhang Qing. I'm a senior Android security research from Xiaomi company. Uh, my main search file is focused on Android security and payment security. My partner by Guangdong, he's a lecturer from Singapore Institute of Technology. But today he has a class for the students. So the next will be me to introduce all of this of our fuzzing method. It's the agenda. First, as we all know, it's harder and harder to find new vulnerabilities. In my talk, I will analyze the reason of the situation. Then I also summarize the traditional fuzzing methods and discuss the limitation. Afterward, I will introduce our new approach. Finally, I will show some vulnerabilities found by our new approach. Here I list some those targets of vulnerability identification on Android. Most security researchers' attention are paid on these areas. You can see from user space to kernel space. At the beginning, researchers focus on the user space, but nowadays, more and more researchers move their attention to kernel space. It has become harder and harder to find new vulnerabilities. As we all know, it's low efficiency to find vulnerabilities just by reading the source code. Because modern projects are becoming bigger and bigger. What's more, some source code is not always available. So you have to do reverse engineering sometimes. What do we do? So someone go after the low-hanging fruit, such as third-party libraries or small-scale applications. Even more, someone also think to use AI for vulnerability detection. However, in my opinion, AI is still just a concept in vulnerability detection. There should be a long way to go to be used for AI for vulnerability detecting. Fuzzing technology turned out to be a effective way to find a vulnerability. Google also said that most of their security bugs are detected using address sanitizer, memory sanitizer, or control flow integrity. Indeed, these tools are very popular and useful. But fuzzing has been well researched and extensively used by Android security researchers to identify the vulnerabilities. Basically, current fuzzing methods take into account two coverages. First one is path coverage, and the second one is input range coverage. Let me show you some example. Path coverage is aimed to cover as many paths as possible. Techniques such as symbolic acquisition, sort, bounding, or model checking. Input range coverage is aimed to offer enough kinds of inputs, such as pitch or AFL. There are also existing some other fuzzing tools such as binder fuzzing or Joseph-based fuzzing. So today, we are going to introduce you a new kind of fuzzing perspective. This perspective is based on famous philosophy that quantitative change leads to qualitative change. This philosophy was proposed by Hegel. This philosophy tells us something changes because quantitative change leads to qualitative change. But we want to ask a question. Is the same for vulnerability detecting? Therefore, in this work, we focus on use this philosophy to improve the existing fuzzing tools. We found that the fuzzing philosophy are very different from the existing tools. So let me show you why and how. This perspective has two core ideas. The first one is quantitative change when fuzzing single function point. The idea is very simple. Indeed, our fuzzing function point only once. We do for the for multiple times. Wherever for quantitative change, when fuzzing multiple function points, we call the function point in several different combinations instead of call one only function point. Now I will introduce these two ideas in detail. For a single function point, we feed the same test case to test one exposed function point. To our surprise, this can lead to some unexpected results. Why does this happen? Let's think about a written write operation may fail after we have written enough wrong and abnormal data to the system. And also, a read operation may fail after we have read enough times from abnormal or unavailable data source. Let me explain this. Let's assume there is a table which include 8 data slots. Each data slot can be put into 10 bytes. When we try to write a very long input to one slot, you can see here, which is what normal fuzzing does. It's safe because the program may have the bounded check. This is the reason the normal fuzzing failed to find this vulnerability, no matter how long the input is. However, we can consider another dimension. We simply write a short input for multiple times. It may overflow on this dimension because developer forgot to check this bound on this dimension. This kind of vulnerability often happens in data storage, such as database or SD card or SQLite. You may be interested in how we found this. At first, it happened when we tried to look at one vulnerability which can't be easily identified from the log. So we had to execute the fuzzing tools for multiple times to reduce the scope. During this, we found another vulnerability, which is completely different from the one we had been trying to look at. The newly found vulnerability is a permanent vulnerability, and at first we didn't understand this case. The cause, so we had to factory reset the phone for multiple times to analyze it. After 2 days exploration, we found out the cause, which is lead to our new idea, quantitative change for vulnerability detecting. This is the demo or example. So this example is test write of clipboard. Clipboard is a binder service in Android. So you can see at the last we try to write some abnormal data to the service. Here we write a string. No matter how complicated the long the string is, no crash is caused. After write into the clipboard for about 20 times, the system crashed. This is because the garbage data is written into the system partition. What's more, it makes the device break, cannot boot anymore. Here is another example. As we all know, the AV partition cannot be written or even flashed phone. However, we made it. When fuzzing one driver, our father managed to write garbage data to the AV partition, which overwrites the IMEI. What about multiple function points? We combine multiple function points in one round of testing. The same as the previous one, we got unaccepted results. Why does this happen? Because some vulnerability only happen under a certain system state, which is reached by a sequence of function calls. That means we should consider the function calls which may change the system state, such as set, get, write, or read, and the other methods. Again, I will introduce how we found this. It's similar to the previous one, but in this case, we just run the tools twice. We found that in the function, the read method A is before the write method B. So the vulnerability doesn't happen in the first time. When fuzzing the second time, the vulnerability happens after the read method is used. So it's the example. You can see the method list. The 8 is read, the 11 is write. At the first time, the write after the read, so it didn't happen. Because in the 11 write operation, it write abnormal data to it. But in the second time, the read after the write, so the read the first time the abnormal data, so the system crashed. To some extent, this method is similar to the essence of model checking. Someone may say the state space will be huge if we consider all the combinations. However, it's not necessary to combine all the function points, such like model checking does. We we only need to combine those core functions, as discussed before, set, get, written, and write and read. Actually, for now, we only did about 10 from 1 to 10 combinations, so it's also bigger. Here is a demo. It's about permanent vulnerability. So let's see the results. Using these ideas, we have identified about 50 vulnerabilities from various mobile phones. It includes code acquisition, or information disclosure, or denial of service. We also were ranked in some vulnerability detecting program twice in this year and last year. Yes. So, thanks. Any question?
So we're opening questions on the floor.
Hello, thank you for the talk.
Yeah.
So if I understand correctly, there are two changes here. The first one is we take the same code path, execution path, and basically try to run it multiple times with different inputs, right? Whatever input would execute that path or that function. Is that correct?
Yes.
To basically have different inputs on the same function rather than executing it just once. Oh, okay. And this, the second change, I was trying to understand. So you try to find the paths which would have like a list of defined function calls. So for example, you want to find an input that both calls read and write, something like that, or was it something different? The second change.
The second is actually we fuzzing one method is first one and the other one, but we combine some methods together.
So it's like one would execute read, another one would execute write.
Yes.
And then you took these two inputs and combined them together.
Yes.
Okay, I see. And the last question, would the tool be open sourced?
Oh, I will update my my tools to Git soon.
Okay, thank you very much.
Yeah.
All right, any more questions?
So how many vulnerabilities are exploitable, or you try to exploit the vulnerabilities?
Because some vulnerability detected in the bounty program, so some vulnerabilities we are not open. Yes.
All right, any more questions? No? All right, thank you.